All right, let's go ahead and get started here. The first question I want to ask is, how's the Wi-Fi holding up here? Is it pretty good? It's okay? Well, the reason I ask is I go to many conferences and speak around the world, and usually the first thing to go is the conference Wi-Fi. But what if you had the capability to bring, say, your conference schedule and share notes and share everything with your friends and with your colleagues and so forth, all without requiring any internet connection, especially if you're traveling overseas where data connections cost. Well, that's really the beauty of the pure web here, and how we're bringing it to you via any number of your devices. So the pure web isn't certainly new, isn't a very new idea. In fact, it's been around for quite a number of years, but it's kind of come to light more often now than it has in the past, with things like Edward Snowden releasing a lot of information about what people collect. When people look at the end user agreements and see what kind of data they're actually giving up, it kind of begins you to think, how much am I really giving up? So today, in this talk, we're going to talk about how you can put the ownership of your data back in your hands and build and think differently about building peer-to-peer applications. So I am a principal engineer and self-described open sourcer in the fact that I went to Party City and I bought a $5 hat to prove it. But no, really, I am a passionate open source advocate, having started my career in Linux and in HP Unix and Solaris and so forth before I ever got into Windows. And I even put libraries out on SourceForge way back when, so I consider myself old school that way. But I work on a number of things that people might know me for, such as the reactive extension, working on React Native, and of course Tolly. And oddly enough, I work for this small startup in the Seattle area called Microsoft. And I've been there for about 10 years, and like I said, I've been a big believer in open source while I've been there. So much so that I was key in bringing Node to Windows in the first place back in 2010, helping set up libuv. And I did other initiatives such as open sourcing a lot of libraries in .NET and JavaScript before .NET was really open source itself. And I, along with Ivan out there, work on a team called the Partner Catalyst team. And he did that awesome talk on AllJoin before. And the idea behind this team is we work closely with customers to solve really hard problems in a really kind of a short turnaround proof of concept kind of thing. So we work on something, then we move on to the next. Well, Tolly, what we're talking about today, is kind of one of those exceptions, kind of a long-term bet. But I like to think that, with all my open source work, that I bring a little bit of metal back to Microsoft. So, we are at the Open IoT conference, so let's talk about that. We're talking anywhere from building robots to controlling refrigerators to controlling your house and so forth. It's an absolutely wonderful conference, and I'm glad that I'm here to learn a lot from all of you. And really, the things are everywhere, but in the typical home scenario, I can hook up a Nest, I can hook up a Raspberry Pi, and these things are everywhere around your house. But in your house, chances are you've got perfect connectivity. So some of those problems aren't really all that interesting, especially and all that challenging, other than making sure you get the protocols right between the two. But I think there are other problems that do need to be solved around security, privacy, and so forth, but that's kind of outside of the scope of this talk. But I'd like to instead talk about big challenges here. What do I mean by big challenges? Like I said, it's not really interesting that I can hook up a few sensors around my house and check if I need to water my plants. what about if we think about bigger, where we have no connectivity, or traditionally haven't had any connectivity in whether it's a dense factory or you're out in the middle of a remote village somewhere? And how do you solve their connectivity problems safely and securely? It's a difficult challenge to say the least, and it's so much needed in the world right now, whether you're helping in disaster relief and so forth. And I think we're all a better world if we all have access to communication and information. So, for example, factory floors are a perfect example of one of these limited connectivity scenarios. Factories usually operate on a pretty low margin in terms of how they operate. And not only that, but when they make investments for a good 20 years. The problem is that you have a lot of interference from a lot of the metal products that you have there, and any number of things that doesn't make Wi-Fi profitable to install completely throughout your factory. We're talking millions of dollars just to retrofit it once, and hopefully it lasts a while. So when you're running this zero margin business, you also have the issues of you might not be on a good cell network because you're out in the middle of nowhere or in a poor neighborhood which lacks a lot of these resources. So when you're making these large bets and large investments, would it be better to invest in smaller form factors and a more offline, online scenario instead of completely wiring up your factory? And this one also comes to me because it's very important in terms of local sustainability and so forth, if you can change the face of farming today. Yes, I know there are a lot of things such as sensors that use radio white space and so forth, but they tend to be fairly expensive and not approachable for the average farmer out there, especially as they're working on very small margins as well. Instead, could you enable them to capture their own data, to share insights, all without ubiquitous Wi-Fi or cell phone connectivity? And like I said, trying to connect all of these outbuildings is not exactly cheap. And we'll even get into even more dire scenarios, such as helping in the times of crisis. We want, when an earthquake happens, when a disaster happens, what's the first thing that goes down? Your cell networks. Cell networks go down, your Wi-Fi goes down, and then you have your first responders who come in, who have nothing more than a few satellite phones, and that's about it. So in terms of how they communicate with you and how you can communicate with your friends, your relatives, colleagues is absolutely essential. Unfortunately, since that cell network goes down, you have no option of doing so. So it makes recovery efforts very, very hard and adds a little extra worry to your friends and family as well. Not only that, but satellite phones are very expensive, and not only that, but they also have a very limited battery life. So the Internet of Things really needs the web as much as anyone, and but not surprisingly, in many scenarios, and specifically the pure web. And to that end, there's Tali. So what I'm finding most interesting about IoT scenarios is, what I find most people doing is just talking to the cloud and cloud-based systems, and those are easy to deal with. However, a peer web makes makes your solution a lot more resilient due to no single points of failure and allowing you to operate in an offline mode as much as possible, giving you the ability to collaborate when you can, and if not, the world goes on. So this is where Tali and the Pure Web comes in, where we can build solutions for the Pure Web that has to deal with hard problems, such as the ones that I've mentioned, and remain functional even when the cloud isn't available. By bringing by bringing Tali to IoT, we enable systems with their close connections to the cloud, but remain fully functional when things aren't available. Now, it's named after the Indian and Nepalese dish, made up of various dishes. According to Indian Thali, it's made up of 6 flavors: sweet, salty, bitter, sour, astringent, and spicy. Now, what it means to us and why we called it that is because when we're building a peer-to-peer platform, we come with a number of things that you can include, including the base package itself, which is the plate, which is the Tali, and then we can bring in things like identity exchange, security, battery life cycle, management, quota management, and so forth. And all of this is going over HTTP and TLS, so if you speak that, we're good to go. So first and foremost, when we're dealing with this is mostly a store and forward mechanism. And what do you need to do that? Well, first you need to enable local discovery, on a per application basis. So as someone is walking down the street, well, I'd want to discover my devices. Given that Tali is your infrastructure, each application should have its own signature, so you can then broadcast it out over any number of protocols, whether it's Bluetooth, BLE, Wi-Fi, Wi-Fi Direct, all join, or name your own protocol. And we felt we also needed to tell the applications, like for example, hey, I've disappeared, or hey, I've come back into range as well. So that's very important, especially when it comes to peer meshing. But when I think about consistency and secure synchronization, I ask myself, how much inconvenience do I want to bring upon a user in order to have high consistency? If I'm building this and I'm building it across the cloud, then I can expect, perfect synchronization and perfect connectivity. But for example, when you're dealing with the peer web, phones die pretty consistently. Phones die whether their battery is out and so forth. And the last thing you'd want to do is lose their messaging. And so any number of things that you'll have consistency problems, we have to manage some way, somehow. The PC could stop operating as well, and power outages and any number of these kinds of things. So this all becomes kind of inconsistent to the user. They want their data regardless of whether they were online or not during the time that message was sent. So these, all of these solutions have issues into themselves. For example, if we're working on different files, or on the same file rather, who wins in terms of writing? Does the last person always win? Et cetera, et cetera. And so there are a number of ways to work around that, but most of them require a PhD in computer science in order to really figure that one out. And I'm not going to necessarily go into all of that, but just to say that there are trade-offs with an eventual consistency model, such as this. And then what we need to do is, need to worry about the security aspect as well, is we need strong identities. For example, your device needs a strong identity, or your app needs a strong identity to uniquely identify who you are to the rest of the world. So we could literally embed into your phone or into your device a strong identity of a public key that can be used to distinguish itself from others. And then, of course, we can use X509 certificates and self-signing for TLS and authentication. But like I said, there are a lot of trade-offs when it comes to security and synchronization. Most of the point, synchronization is really the hard parts, especially with consensus algorithms. But really, when I talked about IoT, I think one of the most important parts that we have is our command and control centers are largely, and our lives are based upon this nowadays. Your phones are basically, at this point, as powerful as your servers were about 5 to 10 years ago. They've got the storage capacity, they've got the compute capacity, and so forth. And really, it does revolve around your entire life, whether you're controlling your home automation, whether you're controlling your life in terms of scheduling and so forth. Really, it becomes the most important thing in your life. And not only does it have all of the communication protocols built right into it, it's got radios, it's got Wi-Fi, it's got cell phones, it's got everything that you need to make a perfect IoT solution. So how would we build something with all of these things in mind, whether it's consensus algorithms, whether it's security, and built in such a way that we have flexibility in terms of what pieces that we bring, whether it's the identity exchange, the quota management, any number of those things. How do we do that? And in sort of a Lego-like fashion where I can just mix and match pieces that I want. Well, the first thing we said was that we had first originally written Tali in Java, as Ivan would know. We first originally wrote it in Java, and then saw, well, we can see if we can put that on iOS, but that was really a non-starter. So the driver for it is we really truly wanted something that would run everywhere. And the most ubiquitous languages for that is either C or JavaScript. So we just went with the easier one. Now, Tali does most of its work in the background here, but not in the web browser. So the web browser is the web browser. But the logic and everything waiting for events is perfectly what a Node itself is really good at. Node, you can stand up a simple HTTP server, you can send up an Express or what have you, server relatively easy to be able to serve data. And so that's kind of why we picked Node as our runtime, because of the pure ubiquity of any number of libraries that we want just work. And not only that, but it works on pretty much any device right now. You can get it for Mac, you can get it for Windows, Linux, ARM, Sun OS, and so forth. So you can get it on a lot of different platforms. And so they don't want just they don't want it just on their maker boards, which ARM is perfectly capable of. They want it also on their personal devices. Now that's a bit of a problem because we want to work with things like the Bluetooth, and we want to work with Wi-Fi and so forth. But you don't necessarily have those deep roots connected into your OS itself without, of course, some third-party add-ons. And not only that, but if we're talking about phones here, there are definite restrictions on what kind of things that you can put on the phone. For example, V8 is not allowed on iOS. Why? Because it has a JITting thing, and everything has to kind of go through JavaScript core. Well, if you replace that with something like SpiderMonkey from Mozilla, then suddenly it will start to work because there are no JITting concerns and so forth. So what we ended up with is we did a lot of investigations early on about shimming Node ourselves to SpiderMonkey using old projects like SpiderNode and other things, and porting it directly to JavaScript core. But that ultimately was kind of a dead end because we realized that would be a heck of a lot of work, and that would set us way back in our time frame. So we had some good news, and the good news was that we had a solution in JX Core. So there was a company called Nubisa that basically put their basically forked Node and then added compatibility, so you could use SpiderMonkey, you could use V8, you could even use Chakra and JavaScript core. So you could deploy literally to any phone or any device that you wanted to. So there was no longer a restriction as to what you could do. The problem, of course, is now that you're stuck pretty much on a 0-10 solution. But the good news is, of course, that you can deploy it to platforms like iOS and Android without any problem. And not only that, but they were able to have quick turnaround for things that we wanted to add as kind of native modules, whether it's PSK support or something else, or kind of mutual auth in terms of self-signed certs and so forth. So we were able to work with them on that. Now here's the bad news. The bad news is that Nubisa, the company that put out JX Core, has gone out of business. Oops. Fortunately, development will continue in terms of they're not pulling it off of GitHub, unlike other people who have done that, and they will continue to work on patches and so forth for the platform moving forward. But to expect parity with the long-term stable version of Node is just not going to happen. So effectively, we're stuck at 0.10 for the near future. But that's not to say that that's totally going to be the case in the future. So Microsoft recently, back in January, they released Chakra Core, which is essentially the JavaScript engine for the Edge browser and Internet Explorer. And shortly thereafter, they did a pull request to basically say, hey, Node, we can easily swap out the JavaScript runtime, and therefore you can now deploy to things like the Universal Windows Platform, or UWP, because of, once again, those V8 restrictions, those restrictions of JITting and so forth. Now you have the ability to kind of choose which end JavaScript runtime you want. Unfortunately, they did not accept it into the main line of Node just yet. Instead, what they did was they put it under, but they did adopt it under the Node.js organization, and they put it under Node Chakra Core. So what's interesting about that now is the fact that now you can build Node and have Node Chakra Core, and you can run that on things like the Windows IoT platforms. You can put it on Edison's and so forth. That's great. But I think it leads to a much longer-term discussion about how we can have more pluggable backends, JavaScript runtimes into Node itself. So I think that's really kind of a catalyst here. And what's also a catalyst here is the fact that Chakra is they're not only working on it to run well on Windows, but they're also working on it for Linux. And why that's important is because now that you could take Chakra and you can run it on Linux, the only downside being is they turned off the JIT for right now, which is fine for most applications, but there are certainly some that require the JIT in order to run. But I think that's cool, and I think if the community pitches in enough, it could absolutely happen in terms of now suddenly Chakra can be deployed just about anywhere, because Linux is just about everywhere. And what's kind of cool is the fact that now you can package this up using the JX Core libraries directly on your phone and use the things that you have built in, such as Wi-Fi and Bluetooth. And now you can actually create apps and upload them directly into the App Store. And in fact, there is one right here on the App Store that actually you can share a shopping list with your friends over Wi-Fi. Pretty simple application, kind of neat. And not to make Android feel left out here is the fact that we also have one also in the Google Play Store as well. So no matter which environment you're on, which covers about 90-some-odd% of the mobile market, chances are you're covered. So as I mentioned, we want the ability to write applications, and we want to use Node for the back end, but we also kind of want to use HTML5 technologies for the front end. And when we tell customers about this, they're like, oh yeah, we kind of get this. We kind of get HTML5 versus having to understand Xcode or understand Java and Android Studio. You have a common thing in HTML5. And so what we do is we use Apache Cordova, and that gives us capabilities directly to the phone's OS as well, such as the camera, to the microphone, to any number of things that we want to get access to. That's not to say that that we can't use another platform as a front end. We could have, just a terminal front end for just things like identity exchange and so forth. But we think, it's a pretty easy thing to do. You could also use things like React Native. Doesn't really matter. You just need a deployment mechanism to do that. Now, we talk about data synchronization between devices. How exactly does that work? Well, it works because what we're doing is we're basically relying on a fairly well-known fundamental way of database synchronization that was made popular by CouchDB. So CouchDB has a really good way of keeping databases in sync by all over HTTP. So it's really kind of a cool thing to have a capability of keeping your data in sync by just giving it an HTTP endpoint. So what we do is we actually take that CouchDB replication, we multiplex it down to the low-level infrastructure, send it over to the other phone, and then demux it back on the other side. So suddenly you can keep your databases in sync very, very easily. But that begs the question, of course, is what if we've got access control lists and anything like that we want to enforce? Well, you can do that, but it more along the lines of is you have to hydrate the changes, put it into a file of the files that you want, and then send it over the wire, and then rehydrate it back on the other side. But that's not really a big deal. But the idea is that you get this automatic replication out of the box, which is really nice. And like I said, since we have such ubiquitous communication on our devices, such as Bluetooth and such as Wi-Fi, we have any number of options for how we keep our applications in sync. And any phone, any cheap phone, any Android cheap phone, any iOS phone will do in this particular case. So, low-end stuff to have people be able to build really powerful stuff is actually very compelling because now you've basically got your server right here. And so how we built it for iOS is the fact that for discovery purposes, we use Bluetooth to basically put out a signal to say to the world that we're able to synchronize with you. And then when we basically make that handshake of when we're ready to synchronize, then we use the Wi-Fi connectivity framework to send data back and forth. Now, on Android, on the other hand, Android has other limitations. So we use Bluetooth. We originally used Wi-Fi Direct to do discovery until we realized that Wi-Fi discovery is a piece of junk that nobody seems to implement correctly. So we instead switched to Bluetooth Low Energy, or BLE, to be able to discover those around you. Yeah, it's a different radio, but chances are we're using it at the same power as Bluetooth, but it's just a different channel to get there. And then from there, we use Bluetooth itself to send the data back and forth. And it's not slow. I mean, when you get this and you realize that I can send Ivan a quick message over there, you'll realize it's actually fairly fast in terms of I can send him a picture or he can send me a picture and a text really, really quickly. Now, how exactly do we respect your rights as a user in terms of handling security? Well, we have those things such as our access control lists on top of CouchDB, but there are other things in terms of using our X509 certs and mutual TLS authentication, to kind of work the magic there. And indeed, we have, for example, if you want a trusted communication with somebody else, you basically will do what we'll be talking about here, which is how do we exchange identities without making our users absolutely hate us? And so that's not exactly easy in terms of how you would actually do something like that. Because in the past we tried, and Ivan in particular tried, using QR codes to basically line two phones up and say, okay, now we're going to talk together. That just doesn't work very well, unfortunately, because you have to match up everything, and then once again you have to be in real close proximity to one another. But what if we could give them an experience much like how you pair your phone with your car and saying, okay, here's the PIN that I'm expecting, and here's the PIN that I'm given. Are they the same? And if they are, then continue on. Yeah, there are chances necessarily during this kind of pairing that you have maybe a 1 in a million chance of having a man-in-the-middle attack in this particular thing. But when you're dealing with not having any cell infrastructure or Wi-Fi infrastructure, the chance of that 1 in a million attack is very, very, very small, because you're going to deal with radio saturation and so forth. Imagine if I'm in a stadium with 10,000 other people. The chances are to have that level of attack is very, very small. But ultimately, what we really want is something as simple as this. We're given a pairing code, we say yes or we say no. And so when I want to exchange data with Ivan or I want to exchange data with someone else, I basically pick you from a list and say, yes, let's enter into private sharing of data so we can send data back and forth directly. Now, we also believe that you have the ultimate right to your data. And that's a really key part of the pure web, is the fact that when you're putting things up in the cloud, who owns it? Well, when you're dealing with the pure web, you have a much more fine-grained control about what exactly goes up to the cloud and what stays on the phone. Which is nice, because if you're doing something around the house or something like that, then you could ultimately control what you give to your utility companies, whatever that. You basically become in control, where you, in turn, can sell that data back to somebody. That's just an interesting idea in the way that I was thinking about it, but ultimately the pure web and having things hyper-local is actually fairly interesting that way. But when you're building a system like this, you ultimately live or die by CI. Why? Because each phone is slightly different in terms of manufacturing. Everyone uses different radios, different Bluetooth stacks, different Wi-Fi stacks, and so forth. So what you really need is to basically buy one of each device that handles Android and all of the models of iPhone that you can possibly pick up. And so what we do is every time that we run any particular pull request on our software, it runs through about 20 Android devices and 20 iOS devices at once. And then it comes through and it gives us a nice little report saying yes or no in terms of its success. And this was all run by Nubisa at the time, but since they've gone out of business, we've actually transitioned that back over to ourselves to continue getting it to work again. But that's really kind of a key thing, is if you're building an infrastructure such as the pure web, you really need to test it on every single device to make sure that the radio works, so that you can caveat it and say, well, it's really not going to work on this particular LG device or whatever. I just picked something random out of the air. Now, where's it actually being used is a good question. And so, increasingly industrial workers are on the factory floor have little to no connectivity when they're trying to work with one another out on the floor. What we found is, once again, that low margin business that they're dealing with, they want to be able to communicate with one another. They want to be able to file incidents and so forth, saying this machine isn't working right. Any number of those kinds of things, as well as have access to diagnostics and so forth. I want to be able to capture some video, I want to capture some audio, and so forth. So we worked together with Rockwell Automation and came up with Project Stanton. And Project Stanton is basically the future of the way that Rockwell is going to be operating their business on their factory floors. That's how much they kind of believe in this technology of the peer web moving forward. So you can follow them at Project Stanton, but I find it very, very interesting and very heartening that they realize the power of the peer web to not only communicate with one another, but also if they embed, for example, hard public keys onto their devices as well, is that they can start to pull off the data from those particular devices as well. So what can you do with it? Well, there are a lot of secure chat and social media networks out there, such as Telegram, FireChat, and so forth. But often, what we find is that their security is often lacking, unfortunately. So we provide kind of a better foundation for how you can build this directly onto your phone. But you could easily build your own social networks. You can build the industrial IoT scenarios and so forth that we hadn't even dreamed of right now. It's really up to you in terms of dreaming big, what you could do with an online-offline scenario. Even the idea that I had for the conference app, where you can start to share data and share pictures with everybody. That also gets, it also becomes very, very compelling. You get this nice offline experience. You can share data with specific people and so forth. Now, here comes a sticky part. When we create these Tali apps, these users have some basic bills of rights. As this effort, we're working on Bluetooth, Bluetooth, Wi-Fi Direct, and the ability to discover and see who you are. But I think that ultimately users have a certain set of rights that we as developers should not violate when we're creating a lot of these things, that they have a right to know what's happening and so forth. So, I'll briefly enumerate Kim Cameron, who is a security expert, formerly, I think still at Microsoft, who is a security expert who came out with his laws of identity. And so we, as engineers, have every duty to ensure that we're following those as we go along. For example, any technical identity system must only reveal identifying a user with their consent. So when you actually launch your app, you have an expectation that I'm going to say who you are to the world, but only if you're consenting to do so. So, I can't make you discoverable without you wanting to, so if, I want to shut that down, well, that app should shut it down. And not only that, but we should also disclose the least amount of identifying information and best use its limits to a long-term solution. But, that's fine, because why we think that is because on your phone itself, you're advertising what? You're advertising your equipment ID, your subscriber number, your MSISDN, your Mac Wi-Fi, your Bluetooth Wi-Fi. We don't need yet another piece of information there flying out in the public for them. So it's more along the lines of only the people who have a right to know should basically be in control of their identity. Now, in terms of, we should also support both omnidirectional and unidirectional for private entities. Therefore, we can't necessarily correlate you based upon other pieces of information. So we also must channel and enable interworking of multiple identity technologies, so not just the ones that we have, but remain pluggable to the ones that you might want to introduce yourself. So Tali, of course, comes with one, but you can go ahead and do that on your own. And so the next one really is talking about that systems have to have an understanding of humans. I don't know how that's necessarily possible without some level of training, so we'll just kind of ignore that one. You know, the unifying metasystem must guarantee its consistent experience through multiple operators, multiple technologies, and that's pretty simple stuff. But really what we want to do is have everyone come and agree on common ways of dealing with identities. But, you know, you might say to this, aren't you full of crap? Because, you know, I've already told you that we have a number of ways of identifying who you are through any number of MAC addresses and so forth. But I would say that the most important part of what we need to do is first do no harm. Now, I'm going to be able to show the app running in iOS, but we have a real problem here. Starting with Android Marshmallow is no longer possible for programs running Android to see the local device's Wi-Fi or Bluetooth MAC address. They just literally took that away. So that's a problem, because what we need is to be able to get that address to be able to advertise it to the world. And so we need the ability to do so, but this won't work because you cannot get any of those addresses, unfortunately, without the system giving the user consent to do so. So imagine if you were trying to say, I want to be discoverable by 20 to 30 people, 40 people, and having to click that consent button every single time you want to advertise is just not a good idea. So it's really unfortunate that they put this restriction in there, and yeah, it's a frustrating thing. So if anyone knows anyone at Google who can help us get around this, we have here an article that we wrote, basically how to survive local P2P and surviving Marshmallow. But if we have any other options, I'm more than willing to listen to that. But the general thing is basically they took away a major capability of being able to reach into the addresses directly. There are ways around that, and you can read about them there. So where are we going next? So as I said, we were kind of a store and forward mechanism, but there's a lot more to this than that. The first off is we can do mesh networking and using Tor hidden services, for example, to do so. You know, when we're dealing with local Wi-Fi and so forth, you know, you can run into natting issues where they don't allow people to talk to one another directly, but we can certainly get around that by using Tor and Tor hidden services. The other aspects are how can we long-term communicate with someone in a much longer range, and how we do that is something called radio whitespace, where you can contact people, say 11 kilometers away. It's expensive and it's not really ubiquitous, but it is a very promising solution, especially if you're dealing with remote areas and bringing access of communication to them. So I'll actually show the demo, and if I'm unsuccessful, I'll show the video. But all you really need to do right now is to get started is you need to install JX Core, and then all you have to do is JX npm install Tali and get started. That's all it takes. So with that, let's make the pure web great again. And so now what we're going to do is we're going to show how to do that. We have Ivan out there in the audience, who's so nice to be able to do this. So I've got my postcard app here, and I'm firing it up. And now what we're going to do is we're going to have him send me a message, and I'm going to send him a message, and he can send you, and you can show everyone that. But this looks like I got a message from him not too long ago. So I'll say hi from stage, and I'll take a picture of everyone just to show that indeed I am talking to people. And use that photo and save. And there we are, and did you get it? Not yet? All right, well, I can show the video instead. But the idea is very, very simple, is the fact that we can have two people be able to put their names in there. So we have Bob and David. We can then save their information. So we now have specifically two users that we can deal with. And then we can create a postcard on each one. All you have to do is just hit once again, the postcard. You can, once again, take a picture of anything that you want to take a picture of. And once you get that, obviously this is actually on an Android device and not on an iOS device. So once again, we prove that it actually does work on other devices. And all you have to say is wish you were here. And save it, and then suddenly, boom. It's that quick in terms of how fast it goes from one machine to the next. So with that, I'll open it up for questions. Anyone? Yes?
So first of all, my compliments to your masochism for being at Microsoft in 2006.
Yes, thank you.
It seems to me there's a reasonable sized team working on this at Microsoft, right?
Yes, to repeat the question, is there a sizable team working at it on Microsoft? Yes.
And the question, actually, the real question is, so what's Microsoft's interest?
Okay. What is Microsoft's interest in this? Well, it's a number of things. For example, enabling things such as the connected factory, other things to help some of our larger partners, such as Rockwell. The other aspects are working with organizations such as the UN for more goodwill efforts to help them with disaster relief and so forth. Yes?
So, Android and iOS are very sandboxed environments.
Mm-hmm.
When you're running Node as a server on these devices, like how are you able to get around, those restrictions?
It's not super sandboxed in the fact that there's a lot. You basically have a lot of freedom in terms of Node once you get in there. The only aspect of how we communicate from the front end to the back end is basically we have an iframe running in there showing off the HTML5 app currently using Cordova. But in terms of like native modules and all of that, we can get those to compile down to what works on iOS and what works on Android fairly easily. So there weren't that many that we had to deal with. The only big one we had to deal with was PouchDB and using LevelDB behind the scenes. But after that, pretty much, since the only real restriction was the JavaScript runtime, none of the other parts really mattered. We could still talk WebSockets. We could still talk any number of protocols. So, anything else as we wrap up? One last question.
You mentioned like Android recently blocked getting your data to your MAC address.
Yes.
I assume that's for like a security reason.
Yes. They claim so. They claim it is. Yes.
What was the security issue? I mean, it would make the wise to block that.
I think it's an overreaction, quite honestly. In the back here in the article that we have here, you can read all about the issues on why they locked it down there. And like I said, I have these slides online. So, with that, thank you very much.